For years, the dream of a truly intelligent video generation felt like a distant sci-fi fantasy, a future where pixels obey our every creative notion and worlds materialize at the speed of thought. Well, buckle up, because that future just arrived. NVIDIA, the absolute titans of GPU technology, have once again dropped a bombshell that's about to fundamentally reshape the creative landscape. At CES 2026, Jensen Huang officially unveiled the successor to the legendary Blackwell architecture, the NVIDIA Rubin platform. This isn't just a chip, it's an entire AI supercomputer ecosystem consisting of 6 new co-designed chips, including the Vera CPU and the Rubin GPU. The name Vera Rubin is a tribute to the pioneering American astronomer who discovered dark matter, the invisible force shaping our universe. It's a fitting name for an AI platform designed to reveal unseen creative possibilities. While Blackwell was a powerhouse, Rubin is being described as an extreme co-design project. It integrates the Vera CPU, built on 88 custom Olympus ARM cores, with Rubin GPUs using NVLink 6, which offers a staggering 3.6 terabytes per S of bandwidth per GPU. This architecture represents the first time NVIDIA has utilized its own custom-designed Olympus cores, which feature spatial multi-threading to physically partition resources for parallel tasks. By combining these cores with HBM4 memory that delivers a massive 22 terabytes per S of bandwidth, the platform is engineered to function not as a collection of parts, but as a singular unified AI supercomputer capable of processing the world's most complex generative video models. But here is the cheese-in, the secret sauce for video creators. NVIDIA has introduced a specialized class of GPU called the Rubin CPX. This is specifically purpose-built for massive context processing. Why does that matter for video? Because generating a high-quality 1-hour video can require processing up to 1 million tokens of data. Standard GPUs struggle with this memory wall. But the Rubin CPX integrates video decoders and encoders directly with long context inference processing, making it the first GPU designed specifically for the massive data demands of generative video. By fusing dedicated video processing hardware with extreme high bandwidth memory, the CPX can maintain cinematic consistency across long durations, without the AI forgetting details from previous frames. This hardware-level integration essentially eliminates the jitter and continuity errors that have plagued AI video for years, allowing for seamless feature-length storytelling in a single-generation pass. Let's talk numbers because they are insane. The Rubin GPU delivers 50 petaflops of NVFP for inference performance. That is 5 times more powerful than Blackwell. It also features HBM4 memory with 22 terabytes per S of bandwidth. For video generation, this means 10x lower inference costs. Imagine generating a high-fidelity video in seconds that previously took hours, all while using a fraction of the energy. This massive jump is largely driven by a new transformer engine featuring hardware-accelerated adaptive compression, which allows the chip to analyze each layer of a video model and dynamically adjust precision. By optimizing data flow this way, the Rubin platform can train trillion-parameter models with 1/4 the number of GPUs, effectively turning the data center into a single, cohesive AI factory. The industry is already jumping on this. Runway, the leaders in AI video, were among the first to port their Gen 4.5 model to the Vera Rubin NVL 72 system. Remarkably, they did it in just one day. This platform is powering what they call general world models, GWM1. These aren't just video generators, they are models that understand physics, allowing for the creation of explorable virtual worlds and interactive avatars that behave realistically. This integration enables Runway's GWM1 family, including specialized branches for worlds, robotics, and avatars, to generate frame-by-frame simulations in real time at 24 frames per second. By leveraging Rubin's 50 petaflops of inference power, creators can now interactively navigate these generated environments, making it possible to adjust camera angles or character actions on the fly during a single session lasting several minutes. This physics-informed approach is a game changer. Older AI videos often suffered from glitching, objects appearing out of nowhere or water flowing uphill. Vera Rubin's architecture, combined with NVIDIA's Transformer Engine 3.0, allows the AI to reason through the physical properties of a scene. It understands how light interacts with surfaces and how gravity affects motion. This isn't just a video, it's a simulation. By utilizing the dedicated tensor cores to solve fluid dynamics and rigid body equations in parallel with pixel generation, the system ensures that complex interactions, like smoke swirling around an object or the weight of a foot hitting the pavement, look grounded and intentional. This shift means the AI no longer just guesses what the next frame looks like based on patterns. It calculates the trajectory of objects based on a deep understanding of 3D spatial geometry and momentum. The real-world impact on filmmaking is going to be massive. We are moving toward a ChatGPT moment for cinema. With Vera Rubin, an independent creator can generate a 4K photorealistic sci-fi epic from a home office. NVIDIA's latest RTX-powered video pipelines are already allowing artists to generate 4K video 3x faster on local hardware. The high-end Rubin racks in the cloud will take this to an industrial scale, allowing major studios to render complex VFX sequences in real time. This shift allows for interactive cinematography, where directors can prompt changes to lighting, weather, or background crowds during a live review session without waiting for overnight renders. By drastically lowering the barrier to entry, Vera Rubin enables small teams to compete with Hollywood-scale production values, effectively turning a single desk into a full-scale virtual production stage. It's not just about movies. This technology is being used for digital twins. Using the NVIDIA Omniverse platform, Vera Rubin can simulate entire factories or cities with perfect visual and physical fidelity. This allows for training robots or testing autonomous vehicles in a virtual world that is indistinguishable from reality. The high memory bandwidth of Rubin makes these gigascale simulations possible for the first time. The new Omniverse DSX blueprint specifically leverages the Rubin platform to create AI superfactories, where digital twins act as real-time operating systems to optimize power, cooling, and robotic workflows at a gigawatt scale. This architecture enables the transition to physical AI, where foundation models like NVIDIA Cosmos learn to reason and navigate within these high-fidelity simulations before being deployed into physical hardware. By integrating Siemens industrial automation with Rubin's extreme co-design, companies can now build fully autonomous manufacturing sites that virtually test every mechanical and electrical change before a single atom is moved. However, it's not all sunshine and rainbows. Even with the chips in full production, experts like Elon Musk have predicted it will take at least another 9 months before these systems are operational at scale and the software is fully optimized. There are also the looming ethical questions. How do we handle deepfakes and copyright in an era where AI can generate a perfect video of anyone, anywhere? NVIDIA is addressing this with confidential computing at the rack scale to ensure data security. The massive power requirements of these Rubin-class data centers also pose a significant sustainability hurdle, requiring advanced liquid cooling and localized power grids to prevent overloading existing infrastructure. Furthermore, the industry faces a data wall, as the high-fidelity video generation of the future will require trillions of high-quality tokens that are becoming increasingly difficult to source without infringing on artist rights or intellectual property. On the consumer side, NVIDIA isn't leaving gamers behind. They've announced DLSS 4.5, which introduces 6x multi-frame generation. This uses the same generative AI principles found in Rubin to create entirely new frames, making even the most demanding 8K games run smoothly. This collaboration between data center-grade AI and consumer GPUs is what makes NVIDIA's ecosystem so dominant. By utilizing the new NVLink predictive algorithms, DLSS 4.5 can now anticipate player input and physics trajectories several frames in advance to minimize latency during high-speed action. This leap forward effectively merges real-time rendering with generative video synthesis, allowing local RTX 60 series hardware to maintain cinematic fluidity even when the base engine is running at a fraction of the output resolution. NVIDIA's Vera Rubin isn't just a new product line, it's a milestone in human history. We are witnessing the birth of a platform that can reason its way through a video, understanding the difference between a falling leaf and a crashing car. It's a tool that will empower the next generation of storytellers and scientists alike. What do you think? Are we ready for a world where video is as easy to generate as a text message? Let us know in the comments. Don't forget to like, subscribe, and hit that bell. We'll see you in the next one.